We have been talking about the quadratic equation, and particularly when the quadratic equation is given to us in standard form. In standard form, it is ax squared plus bx plus c is equal to 0, and a is something that is not equal to 0. A, b, and c are numbers that are in front of the variables or standing on their own when they are a constant. When we have in standard form the quadratic equation, we get to use the quadratic formula. And it has a song. And it goes like this. X is equal to the opposite of b, plus or minus radical b squared minus 4ac, all over 2a. Here's an example of a quadratic equation that we can solve using the quadratic formula. Only this is not yet in standard form. So we're going to have to do some things like subtract terms in order to get things over. So how about if we subtract 2x from both sides, and we get 3x squared minus 2x is equal to 2. We're still not there yet, and so we have to also subtract 2 from both sides. So we get 3x squared minus 2x minus 2 is equal to 0. Now we're ready. And when we're in standard form, we can identify what a, b, and c are. So here, a is equal to 3 because 3 is in front of the x squared term. B is equal to negative 2 because negative 2 is standing in front of the x to the 1 term. And then finally, c is equal to negative 2. And that's a constant because it stands on its own. Now we can sing the song. Ready? X is equal to the opposite of b, plus or minus radical b squared minus 4ac, all over 2a. And now we just have to clean it up. So the radical has negative 2 squared, that's 4, minus 4 times 3 times negative 2. Negative 4 times negative 2 is positive 8, and that times 3 is positive 24. So 4 plus 24 gives me, under the radical, 28. Now let's write the rest. 2 plus or minus over 2 times 3, which is 6. So that's what x equals. There's more that we can do to simplify it. So we got x is equal to 2 plus or minus. Now 28, isn't that the same as saying 4 times 7? And this is all over 6. So that square root of 4 times 7 can also be written as square root of 4 times the square root of 7. And that can be written as 2 square root of 7. So let's fill in the rest. 2 plus or minus 2 root 7 over 6. Well, this is the same as saying 2 over 6 plus or minus 2 root 7 over 6. And you'll notice that we can reduce these a little bit. 2 over 6 is 1/3 plus or minus root 7 over 3 because the 2 and the 6 cancel as well. So that's what x equals. Let's simplify that a little bit. X is equal to 1 over 3 plus square root of 7 over 3. And x is equal to 1 over 3 minus the square root of 7 over 3. And we have used the quadratic formula and sung the song, and we know the answer to that quadratic equation. We said that x is equal to 1/3 plus root 7 over 3, and x is equal to 1/3 minus root 7 over 3, and that each of those are a solution to what we started with. 3x squared is equal to 2x plus 2. Let's go ahead and prove this now. We're going to say 3, and we're going to plug in what x is equal to. 1/3 plus root 7 over 3 squared, and that's equal to 2 times 1/3 plus root 7 over 3 plus 2. Okay, let's go ahead and work the right side first. 2 times 1/3 is 2/3 plus 2 times root 7 over 3 is 2 root 7 over 3. And that 2 is 2 over 1, so I need to turn that into thirds to get common denominators, and so we're going to call that 6 thirds. So we got 2 thirds plus 6 thirds, that's 8 thirds, and that's plus 2 root 7 over 3. Okay, that's about as simple as we can get for the right-hand side. Let's work the left-hand side now. We've got 3 times 1/3 plus root 7 over 3 times 1/3 plus root 7 over 3. Well, that's just foiling, so we're going to do that. 1/3 times 1/3 is 1/9. 1/3 times 7/3, root 7 over 9. And 1/3 times root 7 over 3 is root 7 over 9. And then finally, root 7 over 3 times root 7 over 3 is 7 over 9. All of that times 3. So if we distribute that 3, the 3 cancels with the 9s and turns them all into 3s. And so we end up with 1/3 plus, I'll go ahead and combine those, 2 root 7 over 3 plus 7 over 3. 1 plus 7 is 8, so I get 8 over 3 plus 2 root 7 over 3, and that just so happens to be written on the right, just like that. And that's just proven that the equation here works that we started with. Now, if I did that with the 1/3 minus root 7 over 3, we'd also get the same thing on both sides. So I'm just going to believe that and let us move forward.